So as you look at part E then, we have 2 to the x plus 1 power is equal to 5 to the 1 minus 2x power. This is another example of an exponential equation. And as you look at this exponential equation, you might be tempted to say, hey, we just did an exponential equation in D, so it must be exactly the same technique. Well, no, it's not. So if you think back to part D, we had an exponential expression on the left-hand side, but we had a constant on the right-hand side eventually. And because of the fact that we had a constant on the right-hand side, that makes D different than E. In E, we have an exponential expression on the left-hand side, and we have another exponential expression on the right-hand side. So that means that this is not going to be the same as part D. Well, maybe it's similar to something else we've seen previously. So we have seen the idea that if you can rewrite the left-hand side and the right-hand side in terms of the same base, we can solve things relatively easily. But we have a base of 2 on the left-hand side and a base of 5 on the right-hand side. It's not easy to write 2 in terms of a base of 5. It's not easy to write 5 in terms of a base of 2. So that trick isn't going to help me here either. So what we're going to have to do is use one of the properties that we talked about in section 6.5. And it was one of the properties associated with the fact that logarithmic functions are one-to-one. So what we saw was that if m is equal to n, then log base a of m has to equal log base a of n. So we have a left-hand side and a right-hand side. We have an m and an n, and this particular statement is saying that we can actually introduce logs to both the left-hand side and the right-hand side. Now, what I'm going to say over here is that we're going to take the log of both sides. Now, what log should we use? Well, we can actually take log base whatever we feel like. So if you wanted to take log base 7 of the left-hand side and log base 7 of the right-hand side, you could. However, remember that your calculator really only has 2 buttons associated with logarithms. You have the natural log button and you have the common log button. So I would suggest using one of those buttons. So let's go ahead and do natural log for this particular problem. I'm going to introduce the natural log on the left-hand side. I'm going to take the natural log of the left-hand side. And I'm going to take the natural log of the right-hand side. Now, you might look at this and say, that's uglier than our original problem. And I would agree with you on that. This is uglier than the original problem. But there must be a reason that we brought in these natural logs. So if you think back to section 6.5, we had property 7. Property 7 says that if you have the log of somebody to a power, you can bring that exponent down in front. So I have this x plus 1 exponent, and I want to bring that down in front of the natural log of 2. Now when I do that, I have to be a little bit careful, because I want to take this entire exponent, x plus 1, and multiply that times natural log of 2. The only way that I can take that entire exponent of x plus 1 and multiply it times natural log of 2 is to make sure that I have the parentheses around that x plus 1. So x plus 1 in parentheses, and then we have the natural log of 2. On the right-hand side, we can do the same thing. I can bring this power of 1 minus 2x down in front. So we have 1 minus 2x times the natural log of 5. So now that we have this then, you might look at this problem and say, I'm just not sure how to move forward. So think about this problem in terms of things that feel a little bit more comfortable. Natural log of 2, that's just a number. So if you think about the fact that natural log of 2 is just a number, come off to the side and think about x plus 1 times a number, like 7. If I give you x plus 1 times 7 like that, the x plus 1 is in parentheses, the 7 is outside those parentheses. This is a distribution problem. So you would distribute the 7 through to the x and to the 1. So we're going to do exactly the same thing with this natural log of 2. Natural log of 2 is just some number hanging out outside of this set of parentheses. So if I distribute this natural log of 2 through to the x, I'm going to get x times the natural log of 2. And then if I distribute this natural log of 2 through to the 1, I'm going to get 1 times natural log of 2. But 1 times anything is just that anything. So there we have natural log of 2. On the right-hand side, I can do the same kind of thing. Distribute the natural log of 5 through. Natural log of 5 times 1, that's just natural log of 5. And then natural log of 5 times this negative 2x is going to be negative 2x. natural log of 5. So now that we have this, once again, sometimes people let the natural logs get in their way. You know how to move forward with this problem. Don't let the natural logs scare you. So if I give you a simpler problem, like 3x minus 4 is equal to 7x plus 4, you can look at that and say, oh, I want to go ahead and get the x all together on one side. So if your goal is to get all the x's together on one side on a problem like that, it should be the same goal here. We want to get all the x's together on one side. So I'm going to go ahead and write that as a phrase. Gather all the x terms on one side. So I'm going to choose to put all my x terms on the left-hand side. X times the natural log of 2, it's already on the left-hand side. Natural log of 2, that doesn't have an x, so that really shouldn't be on the left-hand side. I'll come back to him. Natural log of 5, well, that doesn't have an x. The next term that has an x, then, is this negative 2x natural log of 5. That term is currently on the right-hand side of my equation. I want to move him over to the left-hand side of my equation. Now, because this term is subtracted, I need to add 2x natural log of 5 to both sides to make that happen. So let's add 2x natural log of 5, and if we do that, we're going to have an addition of 2x natural log of 5 over here on the left-hand side then. Well, okay, let's keep going. Next off then, I see natural log of 5 on the right-hand side. That's great. I want all of my terms that don't involve x over on the right-hand side. So natural log of 5, that's a great place for him. Now, remember we have this natural log of 2 on the left-hand side? He doesn't involve x either. So I don't want him on the left-hand side. I want him over on the right-hand side with everybody else that doesn't involve x. Well, this natural log of 2 is being added to the first term. So in order to undo that addition, I'm going to have to subtract natural log of 2 from both sides. So let's do that. Now subtract that natural log of 2. So now that we have this then, once again, you should always step back and ask yourself, what did that do for us? Everybody on the left-hand side now involves x. And because everybody on the left-hand side involves x, we can factor out that x. So if I factor out that x, we're going to have x times, x is gone, so the only thing that's left in the first term is natural log of 2. X is gone from the second term, so the only thing that's left there is 2 times the natural log of 5. And our right-hand side is natural log of 5 minus the natural log of 2. So now that we're here then, once again, sometimes people look at this problem and they let the natural logs scare them to a point where they just don't know how to move forward. So look at these natural logs and think about those natural logs as just big old numbers. So I have x times, and then all of this stuff is just some big number. So we have x times 17. And over on the right-hand side, all of those things are just numbers as well. So we're going to have something like 3. Well, if I have x times 17 is equal to 3, in order to get that x alone, I would need to divide both sides by 17. Well, this is exactly the same kind of idea. I have x times a big old number is equal to another number. In order to get the x alone, I need to divide both sides by natural log of 2 plus 2 times the natural log of 5. So my x is going to equal natural log of 5 minus natural log of 2, all divided by this piece, natural log of 2 plus 2 natural log of 5. So at this point, what has happened is we have found an acceptable answer for this problem. Now, remember that the directions asked us to write our answer as both an exact form and as a decimal approximation. This is a perfectly acceptable form for our exact answer. However, it's not the only acceptable form for the exact answer. So if you want to, you can move forward with this exact answer and do a little bit of combining in terms of our natural logs. So let's go ahead and see what would happen if you want to move forward to that next world. So notice in the numerator I have the natural log of somebody minus the natural log of somebody. Well, natural log of somebody minus natural log of somebody, I remember that there's a connection between subtractions and divisions. So I can rewrite that numerator as the natural log of 5 halves. And then in the denominator, remember that thinking about the order of operations, I suggested that you start by working with your exponents. I have this 2 here out in front. I'm going to go ahead and bring that up as an exponent. So it's going to be natural log of 2 plus the natural log of 5 squared. 5 squared is 25. So I now have that this is the natural log of 5 halves divided by the natural log of 2 plus the natural log of 25. Well, now, natural log of 2 plus natural log of 25, I remember that there's another properties of log that says that there's a connection between addition and multiplication. So I can multiply the 2 and the 25. 2 times 25 is 50. So this is going to be the natural log of 5 halves divided by the natural log of 50. Now, this is another acceptable version of the exact answer. So one more time, I'm happy if you just leave it here, but if you want to use some of your properties of logs, you can bring some of these together and have natural log of 5 halves divided by the natural log of 50. So now that we have these two versions of the exact answer, the only thing that's left is to find a decimal approximation. You can either type in the answer up here, natural log of 5 minus natural log of 2, then divide that whole thing by the natural log of 2 plus 2 times the natural log of 5. Or, if you would prefer, you can type in the natural log of 5 halves and divide that by the natural log of 50. Now, either way, you're going to have to be kind of careful about your parentheses and make sure that you're following the order of operations. So each one of these is a little bit different when you type it into your calculator. So what I would suggest is you try both of them and see that you can get the correct decimal approximation. What I'm going to do is write down the decimal answer on the board, and then I want you to try typing it into your calculator and see if you can get that decimal approximation for this version, and then see if you can get the same decimal approximation for the other one. If you don't get the same answer on both of them, more likely than not, it's something about those parentheses. So look at your parentheses and think about how you could adjust the parentheses to make the correct answer happen. So the decimal approximation on this one is about 0.234. Now, because it asked us to round to 3 decimal places, we have to look at that 4th decimal place. The 4th decimal is 2, so that says we don't need to round up. So we'll just go ahead and leave the 4. And our final answer as a decimal rounded to 3 decimal places would be 0.234.